Hello, YouTubers and friends. As you know, I'm an amateur photographer. I don't just use my cell phone for taking pictures. I have a nice Lumix, which I would show you here another time. This is current pictures. I mentioned the Hawthorne Theater recently in a very recent YouTube. I was on my way to the Oregon Convention Center to get my C60 back from OSCON, Open Source Conference. That mission went well. I've been down to that neighborhood since then. I've started to set up around there actually. So this is one of those big musician boxes or buses coming in from who knows where to the Hawthorne Theater. I'm getting ready to set up for some music show. And that's Pepino's to the right. I'm going in reverse chronological order here. Back through, this looks like All Too Human by Nietzsche. I've just been talking about Nietzsche and his breakup with Wagner. That was a topic recently. And I'm also taking care of some canines, so I wanted to show you some pictures of those. And what this video is really about, you're probably starting to wonder, is I actually want to show you some Codesters experiment that I'm doing right now using Python. So this is like the Haida art that like Jordan Peterson talks about this in one of the interviews I saw. He knows about, as a Canadian, he's quite familiar with this North Pacific art. The Jungians tend to like it, I guess, right? I certainly do. All right, so I'm going to jump to Codesters now. Time to get down to business. So I always sign up, even though I'm signed up as a teacher, and go in with my standard accounts. And what I'm going to look at is something I'm not sharing with the world because it's not ready yet. It's more like just keep it in my private space, right? So we're learning about levels of sharing here. We can share at the classroom level, at the public level, and so on. So here, when I hit the green arrow, I'll just show you what this does. I won't even let it load first, okay? Well, I have to let it load. See, this is recognizable from before. Remember, Navajo Blanket is how this started in Codesters a few episodes back. And then it turned into a more hexagonal pattern, which I'm still using. And now we're using collision detection, so that when the UFO senses it's being looked at by one of these sensors, it actually registers this in a data structure. I use a Python dictionary called matrix. I make that up. And as it goes along, it basically associates the color white with every matrix position. And these positions are tuples. They're actually the row and column position, the XY coordinates actually. XY coordinates of each stamp. So now we're going through a second time. As before, the UFO has been removed from the stage down here on line 52, goodbye UFO. But we're going to go by the matrix now. We're going to check every entry that we have a record of. And if we stored that we detected something, then it's going to be a different color. So there was a collision at that point. There we go. So this is where we caught a sense of some kind of colliding going on. It doesn't really look like the UFO. It's not in detail the same. Now, just to make sure this is really working, I think we should pick another sprite, and I'll talk you through the source code a little bit more as we try another sprite. So that's how our sensor matrix reads the presence of a UFO. So this is kind of like doing television. We have a raster pattern, and we're detecting differences in light coming in through the lens and hitting the CCDs or whatever matrix, right? And it's not like we have to emit the light ourselves. The light is coming from the environment. That's why you set up lighting around cameras, to help make it sharp and clear in the matrix exactly what bright colors are there, right? So we're doing something like that. Let's just quick go to a different sprite. So you'll recognize this code. If you go back and scroll back through some of the previous YouTubes, I haven't really changed what I'm doing. I have a plant row, which I had before. Remember, we're looking down on a tractor in the field, and he's going left to right, then back to the start, left to right. So he stamps out hexagons, and it's a little bit staggered, but this is essentially the same as an XY matrix. It's just when we go to volume, you want to think of these as rhombic dodecahedra, and we might be suspending sensors in the ocean, right, at the positions of a CCP or IVM or octet truss. We know how to get there with positive quadrate coordinates if we want. That could serve as a memory address as well for each one of these. And you've got a sensor in the ocean of arbitrary depth, perhaps quite gossamer in construction, but rigid enough to hold everything in isotropic positioning for some time, right? Now you're talking about fishnets and all this kind of what's going to go wrong. Well, that's good. You're thinking like an engineer now. I'm very pleased. So we're over to the left again, and I'm going to call this thing UFO because it's always an unidentified object. But I'm just going to put in person 1, which is just a default sprite, kind of one of the hello world of sprites, and just run it again and see what difference it makes. So we're going to get person 1 is a young lady with, I believe, a young lady. We don't really have all kinds of time to figure out gender now. We just have to see what she rasterizes as. This is kind of like going through TSA. Does she have, is she carrying, is she packing? Is there any reason we shouldn't let her on the airplane? So, or maybe we're looking for a medical thing. Maybe it's some kind of CT scan or one of these things, piece of medical equipment. Okay, so we've scanned way more than we need, but we've got the visual field. Now the question is, how much did we pick up of person 1? And the reason I haven't shared the source code is it's just my first attempt. And what I'm relying on, like I said, is a dictionary set at the beginning as an empty dictionary matrix on line 7. And then, oh, looks like we're getting some Mary there. Does it look like Mary at all? Very interesting. I don't know that this really looks like Mary in any way. It's interesting that this is what got picked up. It looks kind of like edge detection, like maybe if you're entering or leaving the space of the sprite is when it's counting as a collision, whereas right in the middle it may not even see it. So there's a lot more experimentation I would want to do, but you get the idea of the project, right? You're kind of like detecting something that's there using built-in physics. So if you've watched any of the physics videos, there's a physics and events. You're really using events here. I kind of count physics and events as very closely related. But in the event world, we can tell when someone's pressed a key. We can tell when 2 sprites have touched each other. And a hexagon is just a sprite. We call it a shape, a polygon, whatever. All right, so I'm going to save this, and oh, I didn't show you those dogs yet. So let's look at those. Sweet dogs. That's a corgi. I'm sure you can recognize those. I'm kicked back with a couple beers watching some YouTube. So while I'm taking care of these dogs, I'm entertaining myself with drunk history, which, if you know that, it's from Comedy Central. And it's actually a fun way to start to get into some history you might not have known. So it's a very popular TV show here in this neck of the woods, in this zip code. And that's the other dog I'm taking care of. That's one of the drunk histories. So this is about Cleopatra's younger sister and all kinds of intrigue and stuff, which I didn't ever heard that story before. So I'm like, wow, I don't know anything, right? And it's really a funny way that they do it here. Now this guy needs to be rotated, and I think rather than do that, I'll just take a point of stopping at this point, and we'll continue next time. See you later.